40.20. Now this is the ramp CG. Another way to calculate these moments without using a calculator and actually multiplying 210 times 48 giving us 10,080, you can just use the loading graph. Now the disadvantage of using the loading graph is that you will not get accurate values. Let's see how to use the loading graph. Loading graph provides you with a graph that has the calculations done for you. Let's make it simple. This is the rear passenger's line. Let's take the last point on this graph. It intersects 400. So let's imagine a situation in which the rear passenger weighs 400 pounds. When the rear passenger weighs 400 pounds, the moment will be 29,000 because it is divided by 1000. Now 400 times 73 should give you 29,200. You see, doing it using the graph is not way off than the actual value, but it is still not the accurate value. You will get 29,000 and not 29,200. Now this can add up if you have multiple values with an error of 200 or 300 when you are calculating using this graph, because it is divided by 1000. So you can get values only in multiples of 1000 and not in hundreds or tens like 29,250. You will never get that value. That is the only disadvantage. Otherwise, using a loading graph makes it much more easier than using a calculator. A little less accurate though. So continuing with the CG example. Now that we have our CG, we need to make sure that the CG is within the limits. One thing you do before calculating the CG is check if your weight is within the limits. Check if your ramp weight is at or below the maximum allowable ramp weight by the POH. You should always do that first, because if the weight exceeds the maximum limitation, then obviously you will have to remove either fuel or a baggage or a passenger, because you cannot fly the aircraft above its operating limitations. So you first calculate this, you are good to go. Let's now see for the CG. For the CG, we have the center of gravity and moment envelope, or the center of gravity limits graph. You can use either of these to know if your aircraft is within the limits. This is detailed information which will not be of use for your everyday calculation, so I'm not going to delve on this right now. Let's see how to use this envelope. You take a look at your total moment, 88,530. You look for the loaded airplane moment. Now 88,550 would be somewhere over here between 85, which is right here, and 90, which is right there. Let me zoom in a little. So it will be right here. You can use a scale like this and see for yourself. Let's say 88,500 is over there. Then you take a look at your total weight, which is 2,202. Once you know your total weight, you look for the total weight 2,200 and see if the line from 2,200 and the line from 88,850 lies within the envelope, which it does. If you take a look at 88,850, it is right over here, and 2,200 is here. So we are right here. So once you intersect the lines from your total weight and total moment, and if that point lies within the envelope, you are fine. How do we use This graph is also similar in terms of usage. The only difference is it does not use moment, rather it uses the CG and the weight. So the calculated CG for us was 40.2. 40.2 lies somewhere over here, and then the weight was 2200. So when you make a line from 40.2 and 2200, it will intersect somewhere around here, which is again within the limits. Now you can have a simple observation here that in both of the cases the point of intersection is lying on the boundary between the utility and the normal category, and hence this shows that both of these graphs are valid and concurrent. The information that they provide is the same, just different methods of using them.